Alright, so I want to start today by just trying to show you the microscopic view of strong acids and strong bases. So what I want you to take notice of is the reactions at the bottom here, and notice that they're reversible. There's also the particles and what they look like. So water is considered just like our normal water molecule. Then the hydronium ion is is the red one, and then the OH minus is the blue. Now what I have it on now is the water. Okay, now you can see that if I have to show you the water particles, you can see it's full of water particles, and only very, very few of water can actually self ionize and become a hydronium and a hydroxide. This really does happen in water, but very, very few, and it's continuously reversing. Okay, so these two water molecules that have ionized here will go back to normal very quickly, and another one could become ions. All right, so let me take the water off because then you can't see. So this, you can see there are equal hydroniums and equal hydroxides. So this still makes your pH neutral. So I want to start, let's start with strong. So a strong acid. So if you take a look here, this is a generalized hypothetical acid equation here. The H stands for the hydrogen inside an acid, and then the A is for the acid. Okay, so what they're doing here is that they're showing you how the hydrogen from the acid is donated to the water, and you're getting a negative ion and you're getting the hydronium. Notice that we don't have hydroxides here now, and look how many hydronium ions there are. Also, you can take a note that if you look here, they're showing one arrow, which means that does this fully go into ions when an acid enters water? So if you put an acid in water, we used to say that it completely ionizes, or completely ionizes. What we do say nowadays is that it nearly all completely ionizes. So it's not quite anymore. We don't talk about it. There will be a few of these gray molecules in the solution. They're not showing you here, but very, very few. So if I take a look at the weak acid, now take a look, here's our weak acid with our gray molecule, and again the same red and blue. Look how many of the gray there are still in the solution, and our pH is now, I forgot to look at the pH of that one. So this is our strong acid, the pH was 2. Now if you look at our weak acid, can you see that our pH is a little higher? And that is good, because remember, you've got your pH scale that from 7 is neutral, and when you go up from 7 you go into a base, and when you're going down from 7 you go into an acid. So the further away you move from 7, the stronger it is. Okay, so here, or the more ions there are. So this is weak because majority of the molecules of acid are still in solution and they haven't ionized. And here you can see it's a reversible reaction. The blue and the red keep going back into this, and this goes back into that. But you can see at one time the hydronium ions, the red ones, are not that, the concentration isn't that high compared to the strong. So look at the strong acid again. And I'm going to show you what we do with the arrows, because we used to teach it as it completely ionizes. A strong acid completely ionizes, but now we're going to say it almost completely ionizes. Okay, there will be a few of those molecules left over. Let's take a look at a strong base. Okay, now here we have a strong base. Now take a note of how different it looks. The acid was in the water, and it caused the water to ionize. The acid actually turned the water into an ion, whereas here it is actually the base that just separates into its ions. Remember, this is now called dissociation. So here you can see this is strong because, again, almost all of the ion compounds will dissociate into their ions in this water solution. So there is water. If I put the solvent there, you can see the water, but it's better to not put it there. So you can see how strong it is. It's a 12. That's quite a high, a strong base. And there you can see it's a strong base because the hydroxide ions are the things that give it its what makes it a base. Let's take a look at a weak base. Okay, so what happens here, you can see here, this is like a reversible reaction. So you can see the weaker ones are reversible. Now, they're including water over here because remember your water is acting like an acid and it will donate the hydrogen. Okay, so you can see these red ones are the positive ion, and the hydroxides, which is what we are looking at, are all these little blue ones. Okay, and the blue ones are the ones that you can now see. Now take a look, there's a whole lot of B's, just B's. This isn't a compound, this is just an atom. And what has happened is that this atom in water has caused it to become a weak base. We know it's a weak base because there are still the gray B's in here. Not all of it, and very few have reacted and have caused the hydroxide ions. This is very much what ammonia will do. Okay, because ammonia doesn't have an OH, but it does cause a weak base. All right, so I hope that makes sense. I'm now going to go through the notes with you. So please load the next video.